Let's do an example to understand everything we discussed together better. Okay, for this case, the MAR, minimum attractive rate of return, is 15%. It is the same in your calculation as the interest rate we had before, just MAR is more fit in technical terms here, but it doesn't change anything. Any formula, anything that we discuss, just anything you learn about interest rates, you are going to do the same. So here, use 15% as the interest rate. But as I said, minimum attractive rate of return gives more interpretation that what this interest rate mean in fact. Okay, so we have this case over 7 years. It provides you with the market value of the machine. Now you buy $25,000. After 1 year, the salvage value would be 18, 2 year 13, 9, 6, and like that. Operating and maintenance costs are here, and cost of breakdown risk. Now you are 100% should be dominant on everything in this table. So we just finished the phase of understanding the data that we have, and now your challenge that I strongly encourage you to do it on your own before I show you the answer shortly. So here in this column, go ahead and calculate the marginal cost. Marginal cost, and it starts from year 1. So marginal cost for year 1, year 2, 3, 7, and like that. Stop the video and good luck with your exercise. Here is the answer to the challenge, and here you can see the total marginal cost at the end of year 1, 2 until 7. If your answers are the same as here, kudos, very well. And let's go and check the details of this calculation to understand it better. Okay, so here is the raw data that we have, and here we go for calculation. The marginal cost for year 1, that everything is for the end of that period. So here is the marginal cost for year 1, that this is for year 2, and so on. Okay, when we go and check the details, you already know the formula. So see what happens. First of all, when you are calculating the marginal cost for year 1, you go and see the salvage value you had for the beginning of the period. So that opportunity that you had to sell it and get the interest on the money. So as you can see, 25,000 here times 15% the interest rate plus the loss in the salvage value, that is 25,000 minus 18,000, as you can see here, plus the operating and maintenance cost during that year, and the cost of breakdown risk, that now in the first year it is in its minimum state of $5,000. And you see in year 1, 2, 3 it stays minimum, but after year 3 it starts to rise. And we do the same calculation for the other years to get these results. And if we want to see the year with minimum marginal cost, very easily you can get the answer from this table. So here we have 17, 15, 13. So the minimum happens at year 3, and after that it starts rising. Let me give you another example that is not the focus of our topic here, because now we are talking on marginal cost, but try to calculate the UAC and find the connection, association between marginal cost and equivalent uniform annual cost, and especially because when we have that UAC, and to find the minimum cost life, find an association between these two things. A quick refresher on technique 1. If the marginal cost of the defender is smaller than challenger's UAC, keep it. Otherwise, replace it. Now, with this refresher, let's do an example. Based on the data that you see in front of you, specify if a replacement should happen, and if yes, when. Stop the video and work on it. Defender marginal cost, as we usually expect, is increasing, and the challenger UAC is this amount. And of course, we go for minimum because we want to make the comparison a fair comparison. When we want to see if we need to change, if it replace defender with the challenger, we are consider the challenger in its strongest presentation. So it says that the challenger's minimum UAC is 15,430. So let's go. It is for year 1. For year 1, the marginal cost would be 13,250, but the challenger is 15,000. So defender is cheaper, so we are going to keep it for year 1. For year 2, so we are done with year 1, exactly according to that point that I told you. Don't go back. Now we are in year 2, and in year 2 we just go and check how much does it cost us to keep the machine for year 2, about 14,000, still cheaper than the challenger, so we are going to keep it for year 2. In year 3, if we want to keep the defender, it cost us $15,950, but the challenger costs us $15,430. So it's going to be cheaper. So for year 3, we are going to use the challenger, and we are going to do the replacement. And that's it. A quick refresher on technique 2. The first time we reviewed these techniques was in that flowchart, in that map. And as I told you also at that time, when you understand the logic, you automatically, intuitively apply the techniques. The reason I'm telling you, because you know that I'm not a fan of memorizing something or keep something as instruction that you should do this type of thing. No, it should be exactly a rational way of doing it. Regarding technique 1, you notice that you exactly did the rational thing when the marginal cost is rising, and you know that next year marginal cost is greater than now. So the best way is to compare each year marginal cost with UAC minimum EUAC of the challenger, because you are sure if it is now your marginal cost of defender is greater than minimum EUAC of the challenger, for sure next year gonna be greater again. So there is no hope in say that, okay, let's keep it for this year and maybe next year it's gonna be cheaper. No, it's never the case. So that's the reason, just with focus on marginal cost, you can do a solid comparison analysis. That's the logic behind that, because it is increasing and you know next year would be greater than this year marginal cost. So if this year is greater than minimum EUAC of the challenger, just go and replace it. Don't wait for next year. So I gave you this preface to make you ready, or in fact readier for technique 2, in which the defender marginal cost is not increasing, and most specifically it is decreasing. So now you are going to understand the difference better. When it is decreasing, what does it mean? It means that marginal cost of year 1 is greater than marginal cost of year 2. Marginal cost of year 2 is greater than marginal cost of year 3. So they are decreasing. So you cannot compare marginal cost with minimum EUAC of the challenger, because if MC1 of the defender is greater than EUAC of the challenger, still you cannot recommend replacement, because maybe MC2 is smaller, MC3 is smaller, they are getting smaller and smaller. So that's the nuance here, that's the delicate difference here. And again, as I told you, first I prefer to give you the core principles, foundation, then we go for the details. And now you are getting that details. So what you are gonna do when they are decreasing, you are gonna compare the minimum EUAC of defender with the minimum EUAC of the challenger. So it's a very fair comparison, and again, common sense. Just compare the minimum EUAC of these two cases, and if minimum EUAC of the defender is smaller than the challenger, don't do anything, and if it is greater, replace now. And the point that you are seeing now in the slide, that it says if defender's minimum EUAC is smaller than challenger's minimum EUAC, okay, absolutely you shouldn't do the replacement now. But when we should do the replacement, if we shouldn't do it now, keep defender for at least minimum cost life. Because minimum cost life is the time period associated with minimum EUAC. And you just notice that the minimum EUAC of the defender is smaller than the minimum EUAC of the challenger. So in this situation, EUAC is the better one. Until when? At least until the end of minimum cost life. And what happens after minimum cost life? Usually, not always. Usually, defenders' marginal cost increases. And so you do the comparison from that point forward according to technique 1.